Lesson 9, number 1. Factor by grouping, sometimes called the AC method. So this is the method that I showed in the part 1 of the lesson 9 video. 28x squared minus x minus 2. So since this is not 1, I need to multiply A times C and get it to add up to B. So 28 times negative 2 is negative 56, and B is negative 1. So those are the values that I'm looking for when I find my factors of AC. Since AC is negative, I know I need a positive and a negative, or a negative and a positive. So I'll start with negative 1 times 56. That adds up to 55. So that's not what I need. Negative 2 times 28, that adds to 26, so that's not what I need. 3 won't go into 56. Negative 4 times 14 adds to 10. Now notice how these numbers are going down here as I get factors that are closer together. 5 won't go, 6 won't go. Negative 7 times 8 adds to positive 1. So if I go one more, negative 8 times 7, negative 1. And this is a combination that I need. So I term 28x squared minus 8x plus 7x minus 2. So this middle term gets split with the coefficients that you found when you were doing your AC multiplication, when you were doing your AC factors. Now, I'm not necessarily crazy about this because here I would have to factor out a 1 because 7 and 2 don't have anything in common. And that's fine, you can do that. But the other option is you can switch these middle terms around and put the plus 7x here and the minus 8x here, and now you'll see that 8 and 2 do have something in common. But either one of these will work, and we'll do it both ways just to see. But over here, they want you in the first question to find which of these sign combinations would work. Well, the plus and the plus won't work because, look, you've got a minus in here and a minus on the end, so they have to alternate. So plus won't work, but plus minus, look, plus 7 minus 8 would work, and minus plus will work because minus 8x plus 7x would work. So either one of these is a good option, okay? Now let's go with the first one. Let's go ahead and factor the first one. 28x squared minus 8x plus 7x minus 2. Now, in a previous video, we talked about when you have 4 terms, you group the first 2 and the last 2, and you drop your middle sign down here. So 28 and 8 have a 4x in common. And so that gives me a 7x minus 2. Now here you have to be careful because 7 and 2 only have a 1 in common, and that gives me a 7x minus 2 if I bring out the 1. Now I see a common binomial, 7x minus 2, and for my second factor I have to take what's left over, 4x plus 1. So there's our answer, and if you FOIL that out or distribute it out, you should come up with the original problem. And we will because, look, that's a 7x and that's a minus 8, so we'll get a minus 1x. Now, if we switch those around and put the 7x first, it will work, and it actually, for me, it works a little bit better. So it's plus 7x minus 8x minus 2, okay? So instead of the minus 8 and the plus 7, I put a plus 7 and a minus 8. It's the same thing, but just in a different order. So this time I'll take out a 7x, and that gives me 4x plus 1. My middle sign drops down, and I take out a 2, and look, I get a 4x, be careful, plus 1, because a negative and a positive make a negative. plus these two have to match. 4x plus 1, 7x minus 2. So that's number 1. Number 2, factor 49y squared minus 56y plus 16. Now, this is going to be a big number if we do 49 plus 40. If we do 49 times 16, okay? Let's bring up a calculator. Let's see. Okay, so here's a calculator. And I've got to do 49 times 16. 49 times 16 is, look, that's AC this time is 784. And we can definitely do it by the AC method, and in fact I will. But before we do that, I want you to notice something. This is a perfect square. This is a perfect square. This is 7y times 7y, and this is 4 times 4. So before I go through this long AC method, I'm going to test to see if I can make it work with a 7y4 and a 7y4. Now I've got to think about my signs. To get a negative in the middle, okay, I've got to have negatives, but to get a positive on the end, I've got to have two negatives because a negative times a negative gives me that positive. Now I can't assume this is the answer until I check it. So 7y times 7y is 49y squared. We knew that one. 7y times minus 4 is minus 28y. Minus 4 times 7y is minus 28y. And negative 4 times negative 4 is plus 16. And if I combine a minus 28 and a minus 28, so that's minus 28, whoops, let me clear that. I don't have a, okay, I can't do it on here. So negative 28 and negative 28, well, 28 plus 28 is 56, so that's going to be negative 56y. So it does work. So if you'll take the time to observe, if this is a perfect square with two identical factors, and the last term is a perfect square with two identical factors, it may not be necessary to do the AC method. Okay, you might be able, but you need to check it. It turns out that if this is a perfect square and this is a perfect square and this is twice their square roots, 7 times 4 is 28 times 2 is 56, then it's going to work. But if this is a different number, which it could be, it may not work. So if you do it that way, you must check it. All right, I'm going to do it by the AC method too because you need practice with the AC method, even when the numbers are big. So let's do it by the AC method. So we already know it's 784, right? And I'm going to need my calculator for this, and you can use your calculator as well. So we've got 784 right here. And so I'm going to get my calculator back out. And so this is a minus and this is a plus, so I'm going to need two negatives because a negative plus a negative is a negative, but a negative times a negative is a positive. So I know that negative 1 times negative 784 is 784. Then I'm going to do 784 divided by 2. So that's negative 2 times negative 392. Well, the numbers are going to have to be a lot closer together to get a negative 56. But I don't want to skip anything because if I do, it'll be the one I need. So let's do 784 divided by 3. Nope. 784 divided by 4. That one goes evenly. So negative 4 times negative 196. But look, that still adds to negative 200. So it's still too big. So 784 divided by 5 won't go. 784 divided by 6. 784 divided by 7. Negative 7 times negative 112. 784 divided by 8. Negative 8. and negative 98. Now look, that adds to 106 negative. So that's not it. I'm trying to get negative 56. So I'm just going to keep trying on my calculator. 784 divided by 9 doesn't go evenly. 784 divided by 10, well, I know it won't because it didn't end in 0. 784 divided by 11, no. 784 divided by 12, 784 divided by 13, 784 divided by 14, so negative 14 times negative 56. That's negative 70. So look, I'm a lot closer than I was a minute ago. I need negative 56. I'm now at negative 70. So I'm going to go to 15. 784 divided by 15. No, 784 divided by 16. Negative 16 times negative 49. Well, 16 and 49 adds to, that's going to be negative 65. So look, I'm getting closer, but it's not negative 56 yet. So 784 divided by 17 won't go. 784 divided by 18. 784 divided by 19. 784 divided by 20. 784 divided by 21. 784 divided by 22. 784 divided by 23. Yes, I got to keep going. 784 divided by 24. 784 divided by 25, 784 divided by 26, 784 divided by 27, 784 divided by 28. Negative 28 and negative 28. That multiplies for 784, but it adds to negative 56. So I finally have my combination that I need. So I don't need any of this other stuff because none of these add up to negative 56. So I'm going to take my middle term up here and I'm going to write it with these two numbers as my coefficients. Okay? So the first term stays the same, 49y squared, but then I need a minus 28y and a minus 28y and a plus 16. Now you can see why it was a lot easier to test to see if we had perfect squares. That's actually called a perfect square trinomial, and it works sometimes. So you have to be careful if you use it and check it. But I'm going to go ahead and take out a 7y from this pair. I'm going to drop this middle sign down. So 7y minus 4. And these two have a 4 in common. And look, 7y minus 4. So the common binomial is 7y minus 4, and what's left over is also 7y minus 4. Now, this is a special kind of trinomial that can be written as a binomial squared. So that's another way that you can write this answer. And of course, you should fool it to check it. Even though we used AC, it never hurts to multiply it out to make sure you have it right. So number 3, 25 v to the second plus 20 vx plus 4x squared. Now it looks to me like I have a perfect square here, 5v times 5v, and a perfect square here, 2x times 2x, and all pluses, so I'm going to try 5v plus 2x times 5v plus 2x. Now I'm going to check it, because if you use the AC method and you get the right combination, you don't have to check it. But if you're doing this, you need to check it. So I know those are 25v squared and those are 4x squared. But what I don't know is the outer product, 10vx, and the inner product, 10vx. Well, that adds up to 20vx. So this is the correct answer. And since those factors are the same, I may write this 5v plus 2x squared. Now, since you need practice with the AC method, I'm going to do it by the AC method as well. Okay, so let's take a second look at it by using AC. So my AC is 25 times 4, which is 100. And everything's positive, so I don't have to worry about signs. I need the factors of 100. 1 times 100, 2 times 50, 4 times 25, 5 times 20, 10 times 10. Oh, and there it is. 10 and 10 make 20. So I split it apart. 25 v squared plus 10 vx, because I got 10 and 10 down here, plus 10 vx plus 4x squared. I group the first two and the last two, and this sign is going to drop down. So these have a 5v in common. That will give me a 5v plus 2x. And these have a 2x in common, and that will give me a 5v plus 2x. And look what happens. We have 5v plus 2x in common, and then 5v plus 2x left over. So using either method, recognizing that this is a perfect square trinomial, that is, the first one's a square, the last one's a square, and the middle term is twice the square root, the 5v and the 2x. And that's going to fit the perfect square trinomial pattern. You might just do what I suggested, which is just say, look, I know that's 5v and 5v, and that's 2x and 2x. Let me see if 5v plus 2x works, and foil it out, and if it does, it does. If for some reason it doesn't, then you have to go to the AC method. Okay, so now we've got a different kind of factoring that we need to do. Let's do a quick review of what you need to do for factoring. So number one, always take out the greatest common factor. Number two, if the first coefficient is negative, factor out the negative. Okay, we haven't run into one of those yet, but you might in Alex. So if you've got a negative 3x squared in the front, take out a negative. Number three, we count our terms. And that brings us to the possibilities. A, 4 terms, we use the method called grouping. B, 3 terms, we use the method called AC. Now, if the first term is a 1x squared or a 1m squared, you don't have to go through the whole AC, but AC method will work for all 3 terms or all trinomials. And then C is our 2 terms. Those are your binomials, and that's what we're going to talk about in numbers 4 through 8. Okay? Now, if it's a binomial, you've got to look for your patterns. I'm going to list all the patterns and then I'll explain them. A squared minus b squared factors as a plus b and a minus b, where a is just what do you multiply to get a squared times itself, and b is what do you multiply times itself to get b squared. There's a squared plus b squared, which is actually prime. So that's a good one. That's easy if you recognize the pattern. Now, of course, GCF has to come out first before you do anything else. Then you have the cube patterns. A cubed minus b cubed and a cubed plus b cubed. Those patterns apply when you have 3 identical factors. A times A times A, B times B times B. Let me move this cube down here a little bit. Okay, now this is the way the pattern works. One of each of these, A minus B and A plus B. So notice that I use the same sign each time. So if it's A cubed minus B cubed, it's A minus B. If it's A cubed plus B cubed, it's A plus B. Now what goes in here is the tricky part. A times A is left over. Well, that's A squared. Okay? And B times B is what's left over here, and that's B squared. Okay? Because you want a bunch of stuff to disappear, right? We've only got two terms, and if you pull this out, or if you distribute this out, it's got to come back to those two terms. So what goes in here is A times B, and this is always a plus. And this is A times B, and this is always a plus. And where do you get A and B? You go back over here, and you take one of each of those, and you multiply them for this middle term. All right, so those are our four patterns. I'll write them down again as we come to the type of problems that we're doing. So number 4, x squared minus 49. It's x times x and 7 times 7. That's the difference of squares. So you take one of each with a plus sign and one of each with a minus sign. Now you can do it in either order. The minus can come first and the plus can come second, but they must alternate. So this would be x squared minus 7x plus 7x minus 49. And you'll see these two add to 0. So x squared minus 49. And the same thing down here. So a squared minus b squared, there's our pattern, a squared minus b squared, where this is a times a and this is b times b, is one of each, a plus b, and one of each, a minus b. All right, let's do number 5 because it's the same kind. We have 81 y squared minus 49. So if it's a binomial, think of the pattern. This is 9y times 9y, and this is 7 times 7. So one of each with a plus, and one of each with a minus. And again, if I distribute, that's going to be 81y squared minus 63 plus 63 adds to 0, minus 49. Always check these. It makes the most sense. Number 6, 4v squared minus 81u squared. Well, that's 2v times 2v and 9u times 9u. And it's a minus sign, so it's one of each, 2v plus 9u with a plus, and 2v minus 9u with a minus. Now, at first glance, number 7 doesn't fit our pattern. 50 y squared minus 18. Because 18 is not a perfect square. There are not two numbers you can multiply to get 18, and the same thing is true for 50. But if you remember GCF, you have to do the GCF first every single time. This one happens to have a GCF of 2. Once that comes out, 25y squared minus 9, then you have the pattern of the difference of squares. So I'm just going to drop this 2 down because it needs to be my final answer. And here is 5y times 5y, and here is 3 times 3. So 5y plus 3 and 5y minus 3, but you must have the GCF of 2 in the front. All right, and now we're going to do number 8, which is a cube pattern. And I'm going to do number 8 as a sum and as a difference, even though this one's a sum. You don't know if you're going to get an add or a subtract in ALEC. So let's do either one, and you'll see that it turns out that they're the same except for the signs. All right, so cube numbers are like 1 cubed is 1, 2 cubed is 8. You can do these on your calculator to see. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And you'll see that 8 and 125 are both in my cube list. So this 8 is going to be 2u times 2u times 2u, and the 125 is 5 times 5 times 5. So here's my a, and here's my b. Here's my a squared, here's my b squared. So remember, it's a plus b, a squared minus ab plus b squared. So there's a mnemonic device called the SOAP rule to help you remember these. The first sign is the same as the problem. The second sign is the opposite from the problem. And the last sign is always a positive. So that's where the SOAP comes from. Okay? So same, opposite, always positive. So if I want to do this, I've got to take an a and a b with a plus. So 2u plus 5. Now I need a squared. That's 2u times 2u, 4u squared. And I'm going to skip to the back and do the b squared. Well, that's 5 times 5. That's 25. And then for the middle, that's the harder part, just take this 2u times the 5. So one of these is a, and one of these is b, and a times b would be 10u. So it's the same sign, the opposite sign, and always a positive. Now, if we change it to the minus, okay? So it's the same problem, except it's 8u cubed minus 125. But the signs are different, so we have to apply the SOAP rules. I'm going to erase these signs, and let's apply SOAP. So the same as the problem would be a minus. The opposite of a minus is a plus, and the last one's always a plus. So it's exactly the same except for that. And so that's called your sum and difference of cubes. Now, the last two are equations, and we've done some equations before, and we know that to solve an equation, with a degree, that's the highest exponent, that's bigger than 1, step 1, we set it equal to 0. Also, make sure it's in standard form, okay? So I'll make a little note. Standard form. Standard form, everything lines up, and you've got the highest exponent, then the next highest exponent, and then all the way down to you have a number with no visible exponent. Number 2, factor completely, which is why we've been doing all this factoring. That means that you take out the GCF first, you group if there are 4, you AC if there's a trinomial, and you use one of the patterns we just went over if it's a binomial. Once it's factored, you set each factor equals 0. You set each factor equals 0. And then step 4, you solve them. There'd be 2 small 1 or 2 step equations. Now, I'm going to add in a 5, which is not mandatory, but especially on a test, check them in the original equation and make sure they work. So set it equal to 0, make sure it's in standard form, factor it, set your factors to 0, solve each new equation, and check. So 4y squared minus 3 equals negative y. Well, that's not equal to 0, so I need to add a y to both sides. And in standard form, that y term is going to come second. All right, so now we have to do the AC method because we have a trinomial with a leading coefficient is not 1. So 4 times negative 3 is negative 12. Okay? And the factors of negative 12, that will give us a positive 1. It's a negative 12, so we got to do negative 1 and 12, negative 2 times 6, negative 3 times 4, and there it is. That's our combination. Now, I can put them in the split either way, but I think the negative 3 will match better with this minus 3. So I'm going to put 4y squared plus 4y minus 3y minus 3 equals 0. So as long as these add up to that middle term, positive 1y, I can put them in either order. But I like this 4y is going to come out of the first two, y plus 1. Drop your sign, take out the common, 3. And look, this has to be a y plus 1 because a negative and a positive make that negative. So it's y plus 1 times 4y minus 3 equals 0. So step 1 was get it equal to 0. Step 2 was to get it factored. Now step 3, set that first factor equal to 0. Set your second factor equal to 0. And I'm going to put the word or in between because this equation has two answers, not both of them at the same time, but at different times. Y equals negative 1 will be a solution. Over here, I need to add 3 to both sides. So 4y equals 3 divided by 4. Y is 3/4. Those are my two numbers. Those are my two solutions. Now, I did recommend, number 5, that you do a check. So let's go back to this original equation. 4y squared minus 3 is negative y. And let's substitute in this negative 1 and see what happens. I'm going to put a negative 1 in parentheses squared. Now be careful here. A minus and then y is minus 1. So there are two minuses here. So 4, negative 1 times negative 1 is 4 times 1, minus 3. And then negative and negative make a positive 1 on this side. 4 minus 3 equals 1. And that's true. So I know the first one works. So now let's check y equals 3/4. So that's 4. 3/4 is substituted in for the y, so that's 3/4 squared. Minus 3 is minus of 3/4. So I should get negative 3/4 when I simplify this side. Now you can use your calculator to simplify this, but I'll just do it manually so you can see. 4 times 9 over 16, that's your rule of exponents for fractions. Subtract 3 is supposed to be negative 3/4. Well, this is 4 over 1, so I can divide that 4 into this 16, leaves a 4. So that gives me 9 over 4 minus 3 over 1 is supposed to be negative 3/4. Well, fractions have to have a common denominator. So if I'm not using my calculator to do this, I have to make them both have a denominator of 4. 9 over 4 minus 12 over 4 is negative 3 over 4, and that means it checks. Now, it's not necessary or required to check, but it is certainly something you might want to consider doing on a test, because if you factored wrong, you would figure it out when you check it. And number 12, 2u squared plus 11u minus 5 equals u plus 3 squared. Now remember, the first step is to get this equal to 0 and in standard form. So I need to do my u plus 3 squared first. So this side's not going to change while I do u plus 3 times u plus 3. And by the way, it is not u squared plus 9. You have to distribute or FOIL it out. U squared plus 3u plus 3u plus 9 is u squared plus 6u plus 9. And now I've got 2u squared plus 11u minus 5 still on this side. Now to get it equal to 0, I need to move the u squared, so I'm going to minus a u squared. I need to move the 6u, so I'm going to minus a 6u, and I need to move the 9, so I'm going to minus a 9, and notice how I did it to both sides. As I subtracted each one, I made sure I did it on the right side and on the left side. So 2u squared minus 1u squared is 1u squared. 11 minus 6 gives me 5u, and then that's minus 14 equal to 0. And the factors of negative 14, negative 1 times 14, negative 2 times 7, that's the one that adds to 5. I don't need to split or group because, look, there's a 1 here. Those are my factors, u minus 2 and u plus 7. And you can distribute that out to be sure, but it works. So u minus 2 equals 0 if u is 2. U plus 7 equals 0. If I subtract 7 from both sides, if u is negative 7. So those are my two answers. Now let's go ahead and check those just to be sure. So I'm going to check 2 first. 2 times 2 squared plus 11 times 2 minus 5 is supposed to be 2 plus 3 squared. Well, the right side is just 5 squared, which is 25. That one's easy. This is 2 times 4, you got to follow your order of operations, plus 22 minus 5 is 8 plus 22 minus 5, 30 minus 5 is 25. That checks. Let's check negative 7. 2 negative 7 squared plus 11 times negative 7 minus 5 is supposed to equal negative 7 plus 3 squared. This time, that's negative 4 squared, which is 16. Over here, it's 2 times 49, because negative 7 times negative 7 is going to be a positive 49, minus 77 minus 5 is 98 minus 77 minus 5, and if you do that on your calculator, you'll get 21 minus 5, which is 16. So once again, it also checks. So it's a good idea to check these, and it's also a good idea to check all of your factoring by multiplying.